My name's Eve. Thank you very much for joining me this morning. Hopefully I'll be able to tell you about some of the teaching resources that we can offer, and I'm going to talk you through one of them, which involves Lego. So hopefully you saw this in your joining packs. If you'd like to take part in this morning's session, you will need 6 Lego bricks that look a bit like this and 8 that look like that. But if you don't have any Lego, you are more than welcome to just follow along, or you can still do the maths at home, you just can't play with Lego. Will you be able to access the recording again? Yes, you will. It will be on the OR Society's website. I'm not sure if it will be on the STEMtastic website or not, because I'm doing the recording, but I can definitely share it with them if they're interested. Our website, in case you have to jump off at any point, is www.theorsociety.com. That is, on a slide in a little while, but so just before I start talking about operational research and our resources, just to introduce you to me for a moment. I'm the education officer at the OR Society. Sorry, you should be able to see my next slide, and I can't on my phone. Bear with me. I'll try sharing the screen again. Okay, there we go. I think it's working now. So yeah, my name's Eve. I'm the education officer, so I run our education outreach program, which I'll talk about in a little while. I don't actually have a background in maths or in operational research. My background is in chemistry. And then after I left uni, I worked in finance for a few years, and I really love my job now, and I love being able to tell people about careers that involve maths and operational research, because I think there's a lot of appeal for students like me who, with chemistry and finance, I really love solving problems and using analytical skills. And I think there are a lot of students like me who don't know that there's a lot of different careers out there that you can go into with maths. So I'm hoping to, be able to change a few lives or open some minds to this new field. And I also really like baking and eating cake. So as I said, if you've got any questions, you can ask them, and you can also ask questions about cake. Always happy to talk about cake. So the other thing, the kind of order of my slides this morning, I'm going to talk a little bit about what operational research is. I'm going to give you a very brief overview of the company I work for. I'll talk about our education outreach program. Then I'm going to give you an overview of our teaching resources, which are all free, and I'll tell you where you can download all of them in a little bit. And then we'll go through the Lego Furniture Factory, which is, I think, probably our most popular resource, and it's certainly my favourite. But just before I start, I have got a question for you all. Has anybody heard of operational research before? And there should now be a poll on your screen so you can answer that. Okay, so most of you haven't heard of OR before, which is what I expected, to be honest. Not many people have come across it. Operational research is all about using maths and analytical skills to solve problems and to make better decisions. So that's a really broad, kind of vague definition, but it's because there's so much that you can do with this. So I've got a few examples that I can talk you through now. And where this kind of overlaps with the maths curriculum is in the further maths A level. A lot of OR is very similar to decision maths because it's all about making better decisions. So some examples that I tend to use when I'm talking to students is, how would you evacuate the Emirates Stadium if there was a fire? Because in order to get planning permission to build the stadium, they had to prove that they could comply with fire regulations, which involves evacuating all 60,000 people in under 8 minutes. And I did the maths, and that is 125 people every second. So that's obviously a very tough ask. And in order to prove that they could do that and that the building would be safe, operational research was used. So they were able to model the stadium using computer software, and they could run different simulations and look at how people are likely to behave in a crowd, how close together they'll stand, how fast they'll walk. And they can even kind of play with the architecture and go, have we got enough doors? What happens if we put another staircase there? And so I really like this example. This is quite a popular use of OR in terms of designing buildings and making sure everyone inside will be safe. And I once had a student say they would be able to evacuate everybody with secret passages. I'm not quite sure how useful a secret passage would be if no one knows about it, but I liked the imagination. And then a different example is, how do Tesco make sure that you can go and buy whatever it is you want to buy in your weekly shop whenever you go in, no matter which store you go into? Because I think that always seems like quite an obvious thing. Obviously, supermarkets want to have enough products on their shelves for people to buy. But when they've got like thousands of products in hundreds of stores, that can be a really complex decision. And it's one that, if they get it wrong quite quickly, it will start to eat into their profit margins. So a lot of supermarkets will use things like their loyalty programs, so like a Tesco's Club card or a Sainsbury's Nectar card, to analyse what people buy, where they buy it, and when they buy it. And they can use that information to help inform their delivery schedules. So they'll know that if, say, everyone in Birmingham buys milk on a Friday, they need to make sure there's enough milk on the Thursday delivery. Some supermarkets will even do things like factor in the weather to this. So if we've got an unexpectedly sunny bank holiday weekend, they know that everybody wants barbecue, and they'll be able to make sure there's extra barbecue food in their deliveries. And when people aren't panic buying and rushing to buy toilet roll, as we had a few months ago, this works really well. And they can even use OR to do things like optimize their delivery routes. So whether that's going from their warehouses to their stores, using the least amount of fuel, or driving the fewest miles, or getting there the quickest. So there's lots of different decisions in a retailer's business plan that they can use OR to optimize or to examine and say, is there a way we could improve this process? A similar use of OR is how a lot of airlines will use OR to try and forecast where consumers are likely to want to go on holiday, when that will be, and how much they'll be willing to pay to get there. So this kind of forecasting kind of blends maths and marketing quite well, I think, and they'll be able to use it to bid for the air routes that they think will be the most profitable. They'll be able to use it to help set their prices to ensure they're competitive. I think airlines, quite famously, the prices will change and they go up and up and up, and then right before the flight leaves, they drop back down again. And OR is factored into that kind of live pricing decisions. There's just so much that OR can do, and I really love it. This one always feels like a slightly tenuous claim, but supposedly airlines also use OR to optimize passengers boarding airplanes. That never feels particularly optimal to me, but that is the kind of decision that other businesses do with OR that I think works better when it's perhaps like luggage or goods rather than humans that don't want to wait. Yes, so someone in the chat has said this is useful looking at real life situations. I absolutely think so. I think something that personally held me back from studying maths was not really knowing what I could do with it, or kind of, I was sometimes that annoying kid that would say, when do I need to know this maths in the real world? Yes, all of these occasions are when maths is helpful. Um, and then my last example of OR before I kind of get to some of the other exciting stuff is how hospitals and the NHS can use OR. I absolutely love this. I could talk for ages about this because OR is currently being used to help with the COVID pandemic as well, and kind of optimise our use of resources like ventilators. But you can use OR to help with things like staff rotas, which obviously has wide applications beyond hospitals. But hospitals can use this to make sure that they've got the right kind of specialists on staff at the right time. And they can even use this to kind of rota their operating theatres. So if they've got specialist equipment in one room, they can make sure that that's being used rather than a kind of more general procedure taking place when that equipment could possibly be used to help somebody. And I love this next example because I get to say that maths saves lives. A couple of years ago, there were some researchers in, I think it was Cardiff University, who put together an algorithm that can match up patients who need kidney transplants. So if I had a loved one who needed a new kidney and I was willing to be a donor, but we were incompatible, and one of you was in the same situation with one of your family members, this algorithm could potentially pair us up based on things like location to our nearest hospital, blood type, and all the different things that factor into whether you can be a donor or not, so that we can donate kidneys to each other's loved ones and increase the number of transplants taking place. And this algorithm was implemented, I think, about 8 years ago, and there's been 300 kidney transplants take place just as a result of this algorithm matching people up. And yeah, I just think this is really, really cool. So the Operational Research Society, which, as I said, is who I work for, we are the membership body for people who work in or practice operational research, who work in or study operational research. So we're a UK-based organisation, but we have just over 3,000 members all across the world. And we do things like we publish academic journals, we run conferences, we run training events for our members. We also publish some magazines. And we have 2 different outreach arms. So OR and education is one that I'll talk about in more detail in a moment. But I also think pro bono OR is really cool. So I've got a colleague who will match up our members who volunteer their time with a charity or a third sector organisation who would benefit from someone taking a look at how they run their business and making suggestions for improvements or helping with a particular project, because that's quite often the sort of thing that charities can't afford to pay a consultant for. So yeah, we have some very lovely members. But my favourites are the ones who volunteer with me, are in education. And we only have one aim, so it's a very simple outreach programme, but it's also really ambitious. We want every student in the country to know what operational research is. And there's a number of reasons why we want people to know what OR is. So as I've kind of alluded to, it's just this great career and this great area for students who enjoy maths, who enjoy solving problems, to explore. And so often these students aren't really aware of it. And I just want to tell everyone how cool it is. We also want to make sure that we're investing in the future of the OR community. If people don't know that this field is open to them and is available, they won't go into it. So we want to ensure that OR as a profession continues to grow and to help businesses everywhere. And it's just such a rapidly growing and changing field that there's always something really exciting to tell people about or to encourage people to look into. So there's quite a lot of overlap between OR and data science. And there's also a lot of overlap between OR and AI, because a lot of these fields are all about trying to improve the way things are done or to solve problems. And it's just such a fascinating field for people to look at. There's loads of different industries you can work in with OR. And so in order to try and tell students and get students excited about this field, there's a number of different things that we do. So a lot of this is pre-COVID, but we run workshops in schools, we go to careers fairs in schools and universities, we can give careers talks, we also go along to big science fairs, so that's one of my colleagues at the Big Bang Fair at the NEC. We do things like teen tech events and AMSP enrichment days as well. Basically anything that we get invited to. And then I also develop resources for teachers and for volunteers to use to help them explain OR and to talk about OR with students. And I also give talks like this one where I hopefully persuade you all that you should be helping me and talking to your students about operational research. So I'm going to pause here and have a drink and give you a chance to ask questions if you've got any. And then I'm going to talk a bit about our teaching resources. Okay, so our teaching resources, they are all designed to be very hands-on and interactive. They're all meant to be really easy for students to use and really engaging. They're all off the shelf, and what I mean by that is that a lot of our resources are complete packs. So if you were to download one of our resources, you'd get the PowerPoint, you'd get some speaker notes, the student worksheet, you'd get the answer sheet, and any other documents that you needed to run the resource. The only thing that they don't contain is physical materials like Lego. All of our resources are free of charge, so you can download them, use them whenever you want. And they all include real-world examples of OR being used. Just to kind of finish off talking about the resources. As I said, OR kind of mostly overlaps with the A-level further maths curriculum, so that's where we kind of try and target a lot of the information. We'll make sure that it's helpful to students studying at that level, but our workshops can also be run with students much lower down in the school. So I've personally ran our Lego workshop with students as young as like 10 or 11, and they're all designed to be quite flexible, so you could push your more capable students or your older students and ask more questions. But there's also ways to sort of simplify the maths and to simplify the explanations for younger students. So hopefully no matter which age group you teach or whether you do teach further maths or not, our resources will be helpful. And if you have a look at the resources and you don't fancy running them yourself, you can get in touch with me and I can try and match you up with a volunteer who can come into the school and deliver one of our workshops for you. This isn't something that we're currently offering because of lockdown, but if your school was willing to kind of facilitate kind of a Skype call so that a volunteer could talk with the children, then that's something we'd be happy to try and arrange our end as well. The only caveat to our school visits, apart from COVID, is that because it is just me who runs the Oral Education programme, I rely a lot on volunteers. And so matching you up and facilitating a school visit is volunteer dependent. The only thing we ask of you if you would like a school visit is that there is a member of staff present at all times, which is just to help safeguard your students and my volunteers. These are all completely free. And if you would like to have a look at our resources, they're available through our website and also through the TES website, so you can download them all for free there. And if you'd like to have a look at some more information or to request a visit, that's also available on our website, but at a slightly different URL. Hopefully you were all able to download your delegate packs, and it should contain a lot of information in there, but it is all on our website too. And I'll pop these URLs back up again at the end. So I've talked a lot about how our resources are free and how they're really interactive, but what are they? So we've got one workshop that is about theatre booking. So we give students the scenario where they're in charge of seating people in a theatre, and they need to decide what the best way to do that is. So students can try and seat the audience however they like. And then we give them 2 different algorithms to follow. So this resource requires a little bit of cutting up from you guys. So you can print out the seating grid and then cut up the rectangles with the numbers on the left. And then that's how students can try and seat the audience by moving the paper around. And this introduces the first fit algorithm and the first fit decreasing algorithm, which gives them different ways to seat the audience, with an emphasis on making sure that everyone is as close to the stage as possible. And I really like this. I think it's really interesting because the first fit decreasing algorithm gets the audience much closer to the stage, but you can't run it until you've got all of your audience bookings, because you have to sort them before you can allocate them. Whereas the first fit algorithm, you can allocate seating as people book. So I think this is a really interesting example of maths not only being used to solve a problem, but being used in the real world. Because even though one algorithm might make more sense from a mathematical perspective, actually it would be a lot harder to implement in reality, because you would have to wait until like half an hour before the show started to work out where everyone was going to sit. So I think it opens up quite a lot of conversations about problem solving with maths. And this should take approximately an hour to run, so we try and make more fit into a normal school lesson. Another one of our workshops that is normally quite popular is our paper cups workshop, which is all about improving processes. So this one's always really fun because students have to work in teams and it can get a little bit competitive. So students are asked to make paper cups for a sporting event, and they have to work in teams to do that. So there's 4 different steps to our process for making paper cups. There's different kind of shapes, different shaping stages to get the finished product. And this workshop has quite a focus on statistics, because students have 2 minutes in their group of 8 to make as many paper cups as they can. And in their group of 8, there should be 2 students working on each stage of the 4-stage process. And what they'll probably find is that one of the stages is a bit of a bottleneck and it slows everything down. So then what they get to do is have a second go at making paper cups, but that time they can move their group around. So they could put 3 students on one stage and just have 1 student on a stage that doesn't take as long. And then they've got another 2 minutes to make all their paper cups. And then they can use some statistics, some averages, some standard deviation to see if they were able to improve their process the second time. So this one probably ties in slightly better to the kind of main curriculum. So I don't know if you teach statistics, GCSE, but it's a bit more accessible lower down in the school, I think. Not because it's easier, but because it's a bit more familiar to students. And we've got a number of different workshops as well. So I won't talk about these next ones in quite as much detail, but we've got a travelling salesperson problem where students are asked to work out what the fastest way around a theme park is, making sure that they can visit all of the rides and then get back to the gates in time for the coach to pick them up again at the end of the day. So travelling salesperson is a really famous problem in maths, but it can be quite dry with just, can the salesman get to all of the towns? And I think this is quite an exciting way to present that problem and to kind of introduce that it's this millennium maths problem with $1 million prize. And we've also got a workshop on critical path analysis, which is a sort of project management tool that looks at, if you've got a number of tasks to do and you've got, some of them depend on previous tasks, some of them don't, they all take different amounts of time. How do you decide what order to do them all in? What's the fastest way you can complete that task? So the example that we give with students is, how fast can they cook some bolognese in order to have enough time to eat and wash up and then meet their friends in the evening? And I think cooking is a great example of that kind of project management decision making, but at a really accessible level, because most students will have tried cooking, or if they haven't, you know, it's not this kind of strange office corporate thing. It's very relatable. We've also got a number of resources that aren't workshops, they're more kind of worksheets. So these resources can be used as homework, perhaps after one of our workshops, or just when you're teaching decision maths anyway. So we've got worksheets on linear programming, on critical path analysis, and on different algorithms. So I'd encourage you to have a look at those as well. And now I'm gonna, again, have a little pause, give you a chance to ask questions, and then we'll talk about the Lego Furniture Factory. So now is the time to go and grab your Lego if you want to take part. Okay, so for our Lego Furniture Factory, you have got a challenge, and your challenge is to help Swede Build, who are most definitely not a parody of IKEA. They want to launch a new range of dining room tables and chairs, and you've been asked to help them work out which combination of tables and chairs they should make in order to maximise their profit. So the first thing we need to do is to work out how we're going to solve this problem. We're going to use some modelling. So Swede Build only have a limited amount of resources to use. So we're going to replicate that with our Lego bricks, and therefore we can only use a limited amount of Lego bricks. So as I said, 6 of the kind of 2x4 ones and 8 of the square 2x2 Lego bricks. And in order to model the furniture, we're going to use these designs. So tables should use 2 bricks at the bottom and 2 on the top, and chairs should look like this, with a small base, a small back, and then a wider seat. And the first question we ask students is, how many tables and chairs can you make with your limited amount of bricks? So if you're playing along at home, if you've got the student worksheet for this workshop, then feel free to fill out the table in it. Or if you've just got a pen and paper to hand, feel free to just sort of jot some things down. And while you're all playing with Lego, this is a good example of the way that you can adapt our resources for different audiences. So if you're running this to cover the further maths curriculum, you can just keep going. But if you're running this for slightly younger students, now is a great chance to talk about modelling a problem, why you might want to do that, how you might do that. So once the students in that room have all had a go at building some furniture, you can ask them, two different students opposite ends of the room, to hold up chairs that they've made and what they notice. And what they should hopefully notice is that all of the chairs are exactly the same because we've built to a common design. And why might a furniture company want to build to a common design? Well, they might want to reduce the number of materials that they're using so they can manufacture more chairs. They might want to make sure that all of their chairs look the same. I think it's quite an unusual customer that wants to buy mismatched chairs to all go around the same table. And you can also talk about the kind of materials that a company like Swedebuild would be more likely to model with in real life than Lego, whether that would be wood or plastic or metal, maybe even glass for the table. So you can kind of bring a lot of real life considerations into this workshop if you'd like to. So if you're still playing with Lego, please feel free to carry on. I'm going to move on just to make sure that you guys are all done before 11, so you can go to your next webinar. And the second question that we ask students is, well, now you've built some furniture, don't forget we're trying to maximise that profit. So we need to think about how much the raw materials cost, and therefore how much it costs to make the furniture. So how much will it cost to build a chair if the square bricks cost £3 and the rectangular bricks cost £5? How much will it cost to build a table? And I'm not sure how many of you are using the student worksheet, but there is a table there that has number of chairs, number of tables, cost, and so on. So students can fill out this table as they go along. And you can too. So once we've worked out how much it's cost us to build furniture, the important question is how much profit can we make when we sell our furniture? So if it costs us £11 to build a chair and we can sell this chair for £21, how much profit have we made? How about for the table? And I think this is quite nice because the numbers that we use aren't really kind of big and complicated. And I have had very, very keen kind of like 7 and 8 year olds solve this problem when we ran it at science fairs. And once we know how much we can sell our furniture for, the important question is which combination of tables and chairs that we've made, whether that's 0 tables, 4 chairs, or 3 tables, no chairs, or somewhere in the middle, gives us the most profit. So for those of you that are having a go, you can try and answer the poll and see which combination you think is the most profitable. If you're not playing with Lego and you want me to move on, feel free to give me a message in the chat. Oh, apologies. I didn't realise that the poll would make the numbers disappear when I put it up. This is the first webinar I've done using polls, so a few little kinks to iron out, I think. So we've had a few guesses, and I'm gonna end the poll now. I'm very sorry if you're still working, but those of you that aren't, I don't want to keep you. So the correct answer is 2 tables and 2 chairs. That gives us the most profit, because if we, hold on, I can't find the notes now. 2 tables and 2 chairs should give us a profit of £52, because it costs us £54 to make the furniture, and we can sell it for £106. So we're awesome. We figured out what Swede Build should do to maximise their profit. But how would we have gone about solving this if we'd had much different constraints to use? So when we only had 6 bricks and 8 bricks, this was quite an easy problem to solve by essentially what was trial and error, trying to build different combinations and then doing the maths to work out which was the most profitable. But if we'd had, say, 6,000 and 8,000 bricks, or 6 and 8 million even, there's no way that we could have tackled this with trial and error. We'd have needed a more systematic approach, which is where the maths comes in. I'm going to do a little bit of algebra now. So the first thing that we need to do is decide what we're going to use to describe the constraints that we're working with in order to model them and work out how to maximize our profit within those constraints. So we're going to let T represent the number of tables, and we'll let C represent the number of chairs. And the first thing to do is write down an inequality that links the number of tables and the number of chairs to the number of rectangular bricks that it takes to make the furniture and the number of bricks that we have available. And then once we've done that, we're going to do that again, this time for the square bricks. So we need to write an inequality that links the number of tables and chairs in the bricks they use to the number of bricks that we have available. And then once we've done that, we will hopefully have inequalities that are 2t plus c is less than or equal to 6, because it takes 2 of the rectangular bricks to build a table, 1 to build a chair, and we've got 6 available. Similarly, it's 2t plus 2c must be less than or equal to 8. And now that we've got a pair of inequalities, we can find some coordinates and we can plot them on a graph. So the first thing we need to do is find our coordinates. So for now, we're going to assume that these are equalities rather than inequalities. If 2t plus c is 6, and we say that t is 0, what must 6 be? Sorry, what must c be? Likewise, if we set c to 0, what must t be? And this is fairly straightforward. I won't spend too long. So if t is 0, c is 6. If c is 0, t is 3, which gives us a pair of coordinates 0, 6 and 3, 0. We can then repeat this again for the square bricks. So what's c when t is 0? What's t when c is 0? And we should get coordinates 0, 4 and 4, 0. And now that we've got two pairs of coordinates, we can plot two lines on our graph. And here's a graph I plotted earlier. So the blue line represents the blue rectangular bricks. The red line is the red square bricks. And what I've done here is I've plotted these lines running through the coordinates that we worked out, but also extending into the negative regions on the graph. Now, this is a good chance to ask students, don't forget, this is a real life problem that we're trying to solve. Will the possible solutions be found in the negative regions of the graph? Hopefully, the students will realise quite quickly, no, we can't have an answer in the negative region in the graph because you can't manufacture -1 chairs. And then the other thing we need to consider is that to plot these lines, we treated the inequalities as though they were equations, but actually they're not. And so bearing in mind that these are less than inequalities, what side of the lines is our answer likely to sit on? And students will hopefully find that the feasible region, the region in which all of our answers must lie, is the region I've shaded in purple here. When we run this in class, we do give students time to plot the graph themselves and to, participate in all of this themselves. But assuming that you guys don't want to spend your Saturday drawing graphs, I'm just moving ahead a little bit now. And so, as you can see, I've plotted the possible furniture combinations in the feasible region, so that's the grey diamonds. And all of these solutions, apart from one, lie on an edge or on a corner. And the way that this helps us to reduce the number of possibilities we have to try is that the correct answer must lie on a corner or along an edge, because if you think that we're trying to maximize our profit, if we were to plot profit on the graph, it would be a straight line, and you would want the profit line to just intersect with the feasible region at an edge or on a corner, because that's where the profit would be greatest. So once you've drawn your graph and you have a feasible region, you can test each of the corners, which is still trial and error, but much fewer possibilities to try. And as you can see, we have 2 chairs and 2 tables on one of our corners, and so we can confirm that we did get the right answer earlier. And we've solved the problem. We can say with certainty that the best combination of furniture for Swede build is 2 tables and 2 chairs. And what you guys have just done, or what your students will have just done, is a type of maths known as linear programming. Linear programming is a really widely used technique in operational research because it's all about optimizing your problem or optimizing your results when you're dealing with some constraints. So that could be limited number of resources. How do we maximize our profit? Or you could flip it and say, well, I want to reduce my costs. How can I reduce my costs when I've got these set of constraints that I need to work with? And at this point in the workshop that we would run for students, I'd go through some other examples of OR, and I'd talk about an example of linear programming being used. I'm not going to go through more examples of OR now because I explained all of that at the beginning. The example of linear programming that we use is to do with how food banks can use linear programming to optimize like packages of food that they put together. So whether that's thinking about ensuring that it's providing balanced meals for the people the package is for, or taking into account dietary preferences. So that's quite a nice use of maths, being able to help people again. And that just about wraps up everything I wanted to talk to you about this morning. So just to remind you all, if you want to have a look at our resources, if you want to download the Lego workshop or any of our other workshops, you can do so on the TES website. You can download them on our website, and the information and the visit request forms are also available on our website. So thank you all very, very much for listening to me this morning. I hope you've enjoyed it. And I don't have another session next, so if any of you have any questions, you can stick around for as long as you like, and I'm happy to chat and answer your questions. And if you think of any questions after the session, you can get in touch with me. So our website's there. You can tweet at me, which is @OWareneducation. And if you want me to send you the delegate pack because you didn't get it, or you want the slides or any information at all, you can email me, which is education@theorsociety.com.